right, the first thing we're going to get started with, we are going to show both 1D and 3D setup for bolt tensioning. Let's go ahead and start with the solid model. Very simple model. There are a couple components in here. It will be easier to see what I'm doing if I turn off these and just look at my fastener. Under your analysis tab, where we set up things like loads and boundary conditions, we can hit the pretension manager, and this is where we're going to set up pretension for 1D and 3D bolts. We'll add a 3D bolt, and I think the easiest way to go about this is just to use the auto surface creation, but if you like setting up surfaces manually, you can always do that through create new surface. In here, we're going to select our base node, which is where the actual cross-section or the surface will take place. Do it here, just so I know it's in the lower half. The direction will be up here. Hit OK, and it will take me back here. I should have hit apply, though, before doing that. No worries. Hit apply. All right, now my surface has been created. I can either review it from here and make any changes that I need to, or you can review it back in that pretension manager. So hit review here, and you see we have this nice surface that's been created, and it is going to apply a force or some kind of displacement in this direction. So this will be in the global direction in Z. Hit OK, and now we have all of these entities here. Some of them are going to be optional for Abacus, but I'm going to go ahead and fill them out anyway, just to be explicit. So from here, we can either specify some kind of force or a displacement to specify how this tension is applied. We will go and select C load. We'll put in some load magnitude. I'll just say 1 for now. And then my understanding here is that Abacus, if you don't specify a direction, will just take it normal to the surface you've created, but I always like to just go in here and specify anyway when you move between different solvers and things. But you can just click here, it'll orient. You can also orient this, but I think from the vast majority of people, we just want it to be in this direction, normal to the surface that's made. In the Z direction, and from here, we can say, OK. In our loads now, we get a pretension that has been specified. If we go in and create our load step, we apply our loads and boundary conditions just like we would for any other load you're applying to your model. So I'd select pretension here, as well as any constraints that I wanted to put in the model. Pretty much be on my way. Let's switch gears here and head over to do a 1D example. I'm not going to save that, and I will open this bolt pretension up. For this guy, in HyperMesh, in order to do the setup of the, I don't know what to call it, the node, the reference node that Abacus uses, that's something that seems relatively specific to them. We have to have some node that helps do the pretensioning here behind the scenes. So it can actually be, I think, anywhere, but just for ease and kind of model management, I'm going to put it in between these two nodes so I have some idea of what this random node in a larger assembly might be doing. Coming over here to geometry, the default here is going to be to create a point, which is a geometric entity in HyperMesh. What we actually want here is a node instead, which is an FE entity. If I hold down Control and click two nodes within HyperWorks, I can specify how many midpoints I want to create. So for instance, if I was doing something else and I wanted to have 3 evenly spaced nodes, I could do that. 1 is plenty for us. No need to create anything extra. Again, we just head over to Analyze, go to the same Pretension Manager, and of course this time we have 1D elements. We'll make a 1D bolt. Then the process here is pretty much the same. Let's say I want to do a boundary here. That set has already been created. This set just refers to this node. And then I put in here, I forgot to check the scale of this model, so let's just keep this small and say 0.1 is the displacement I want to enforce. Again, it is my understanding that Abacus will take the starting and ending point of this beam if you don't put in an orientation and essentially just force that in the direction from node 1 to node 2. But we know the orientation. Let's go ahead and enter it. Normal to this surface, but a lot of our tutorial models are easy in that they are aligned in the global axis. So we can double check here and make sure that this is actually going in the direction we want. And it is. We are ready to go now. We have this pretension load collector that is also made in the instance of these 1D elements. Pretty quick session today. Just wanted to show the pretension manager and the ease of setting this up.